So, good day to everyone, and warmly welcome to the webinar series on industrial water and wastewater management challenges and solutions, jointly organized with University of Peradeniya, RMIT University Australia, as well as Joint Research and Demonstration Center, Peradeniya. There are a few things to be followed. So, mute all your microphones and turn off all your videos. If you have any questions, you can type in the Q&A session. You can ask, as well as you can inbox to the chat box for the all penalties. And you can use the Q&A session and chat box only to type question to the resource persons. Further questions and clarification may address via email after the online session. So we have 5 webinar series, industrial and wastewater management challenges, rainwater harvesting and stormwater management on 13th May, and the 3rd of June, brackish and seawater installation, reverse osmosis, RO and other technologies, and the 17th June, action and zero liquid discharge concepts for industry, and the last webinar will be on the sensing, digitization and water. So all of your participation, we hope we highly appreciate for this upcoming and today webinars. So we have a very big objective. This webinar series was organized to develop a research and development platform to provide solutions for the problems found in different industries, institutes in the water sector. So we know that there are huge gap to fulfill that reach. I'm glad to say that Joint Research and Demonstration Center is now open at the premises of the University of Peradeniya. So I'll go through some of our facilities. So it have different facilities for technology development, conferences, as well as advanced laboratories. So I'll go briefly. So this instrument is worth more than 600 millions, and the high-end technology for all the water quality parameters, as well as we can develop some technologies with you. So I would like to welcome all for our participation for this JRDC. So we have some volatile organic laboratory, inorganic laboratory, as well as some other facilities for your use, as well as our accommodation, as our control calls are available for your participation. So I'll briefly describe the program, industrial water needs and wastewater management. So the tools and to implement integrated industrial water will be developed by the Professor Jagathisan from the university, and thereafter application of membrane bioreactor in industrial wastewater treatment will be delivered by the Professor Yang Sung Wei, Director of Water Pollution Control, China, and the panel discussion will be held by Dr. C.S. Kalpage, senior lecturer in University of Peradeniya. So I would like to cordially invite Dr. C.S. Kalpage to moderate the session.
Okay, good morning to you all. Good morning to Sri Lankan participants. Maybe good afternoon to those who are joining from Australia and China. And good evening to those who are joining from USA. So this is the first seminar of the series of 5 seminars, mainly targeting to promote integrated water resource management in Sri Lanka, and also to identify prevailing water management issues. Particularly, this more emphasis is on industrial water use, wastewater treatment, etc., in Sri Lankan industries. So the first of these series of seminars, the first one is titled Industrial Water Needs and Wastewater Management Challenges. And as you have been given this introduction to today's session. So this session will run from now onwards till 11:20. First of all, we will have two speakers, one joining from Australia, the other one from China. Then thereafter, we will have a panel discussion from 10:45 onwards. Yeah, briefly, this is the agenda for the day. Okay, let me introduce our first speaker, Professor Veeraya Jagathisan. We call him Jaga. He's not a new person to Peradeniya particularly. So Professor Veeraya Jagathisan is a professor of environmental engineering and the director of Water Effective Technologies and Tools, WET Research Center at RMIT, Melbourne, Australia. He graduated from University of Peradeniya. He's a very proud alumni of our faculty, on faculty University of Peradeniya, Faculty of Engineering. He conducts research on water, that is treatment, distribution, modeling, then wastewater, mainly membrane bioreactors, recirculating aquaculture systems, application of membranes in agriculture, modeling saltwater intrusion in coastal regions, and then resource recovery, mainly from mine tailing ponds, recovery of dyes and salt from textile industries, and novel and hybrid technologies, including forward osmosis, membrane distillation, etc. He's the editor-in-chief of Environmental Quality Management Journal, published by Wiley, and the editor-in-chief of Applied Environmental Science and Technology for a Sustainable Future, a book series published by Springer Publisher, and he's involved in this since 2015. He's also a secretary of Stormwater Quality Improvement Device Evaluation Protocol, SQIDEP, governance panel of Stormwater Australia, and he's serving there from 2019 until 2022. And he's also a consultant of Beijing Environmental Protection Industry Development, Beijing City, China, since 2019. He has more than 400 publications in the form of peer-reviewed journals and conference articles, books, book chapters, editorial, and commercial in confidence reports. He has secured more than 1.5 million Australian dollars from various grant schemes to conduct his research. And he has helped us a lot to University of Peradeniya, our graduates. He usually recruit them as postgraduate students at RMIT. So I kindly invite Professor Jagathisan to present your presentation, and you have approximately 20 minutes for your presentation. Over to you, Professor Jagathisan.
Thank you, Dr. Kalpage. I would like to use my presentation, and I have audio so you can listen, and let me share my screen with you. I'm sharing my screen with you. Hopefully you can.
Good day, everybody. Thank you for attending the first webinar of a 5-part webinar in a series on industrial water and wastewater management, challenges and solutions. My name is Veeraya Jagathisan. I am a professor of environmental engineering and the director of Water Effective Technologies and Tools, WET Research Center at RMIT University in Melbourne, Australia. I would like to share an overview on the tools and techniques available to implement integrated industrial water management and wish to listen to your views, needs, and future plans. I will begin my presentation with acknowledgement of country. RMIT University acknowledges the people of the Woiwurrung and Boonwurrung language groups of the Eastern Kulin Nation on whose unceded lands we conduct the business of the university. RMIT University respectfully acknowledges their ancestors and elders, past and present. RMIT also acknowledges the traditional custodians and their ancestors of the lands and waters across Australia where we conduct our business. I would like to give a brief summary of our center. The center, with 31 members from various disciplines, aims to develop technologies and methodologies for managing quality and quantity of water by actively engaging with the community, government, and industry. It also enhances research training of undergraduates and postgraduates to prepare them work ready. The center's research covers the entire water cycle under the following three major themes: water resources and management, water and wastewater treatment and reclamation, biosolids and bioenergy. Our research activities also contribute to many sustainable development goals. We have many national research partners as shown on this slide. We have formed international consortia on appropriate technologies for water and sanitation, resource recovery and concentrate management, and stormwater management. We also have collaborations with South American universities through Victorian government. We have editorship in a journal with Wiley and a book series with Springer. The presentation will briefly cover the aims of the webinar series. It will then define what is integrated water management and provide examples on how to implement integrated water management. The roles of the stakeholders and future plans also will be discussed. The aims of this webinar series are knowledge sharing, generating dialogues between industries and universities, leading to collaborative plans and actions for a sustainable future. The webinar series will cover water and wastewater management, rainwater and stormwater harvesting, desalination, cleaner production and zero liquid discharge, sensing, digitization, and water 4.0. Let us define integrated water management. A simple definition is utilizing all the alternative water resources in a sustainable manner to preserve the fresh water for current needs and for the future generations. Then what are the alternative water resources? Rainwater, treated wastewater, stormwater, brackish and saline water. While doing so, we also make sure to recover resources such as nutrients, salts, and energy from the waste streams. Let us look into the first alternative water source, the rainwater. These are the statistics for Australia. 274 billion liters of rainwater can be harvested annually. 26% households capture 177 billion liters of rainwater, which is 9% of the residential water and worth 540 million Australian dollars. Regional areas, of course, capture more rainwater. In Sydney and Melbourne, rainwater harvesting and water efficient appliances contribute 80 gigaliters and 55 gigaliters of water respectively. These data demonstrate that rainwater harvesting is the first and most efficient element of an integrated water management system. These are typical illustrations of capturing rainwater from roofs with a simple first flush systems to remove the debris carried by the rainwater at the beginning. All the industries should consider seriously to utilize this option. What could we do in Sri Lanka? I can put forward some suggestions, but we would like to hear from you more on this. Some suggestions are: conduct a review to consolidate existing data, evaluate the potential in implementing the rainwater harvesting, have demonstration projects, I will show an Australian example later on. Develop long-term plans, including policies, regulations, etc. Let us move on to our second alternative source, treated wastewater. Most of you will be familiar with this type of process flow diagrams. By treating wastewater to different degrees, we can produce different classes of water fit for different purposes. This will also reduce the treatment cost. Water utilities managing domestic wastewater treatment plants are placed ideally to tap into this resource. Water quality standards of different classes and the treatment required to produce those classes along with their applications are shown in this table. Agriculture industry can benefit greatly from the reuse of treated wastewater. All the other industries can explore the possible uses. Sometimes they may require additional treatment. This is an example of how a precinct-scale sewer mining plant and smart rainwater tanks can supply fit-for-purpose water to a development. Fisherman's Bend in Melbourne is an urban renewal development. Will have around 100,000 people in 2050. The fit-for-purpose water system can reduce the potable water supply by 45% and reduce the wastewater flow to the sewers by 50%. Many more such examples for small and medium-scale developments can be found from the links shown on this slide. This is applicable to industrial estates as well. We have experience in developing treatment systems to reuse treated effluents from car wash stations, aquaculture farms, mine tailings, etc. Membrane bioreactors can treat wastewater with organic pollutants and can produce Class A water. For example, car wash stations in Australia can produce 35 billion litres of wastewater per year, and if it can be treated and reused, around 77 million Australian dollars can be saved from treatment costs. Similarly, a zinc mine producing 900 cubic meter of tailing effluent a day can have chemical treatment followed by membranes to produce recyclable water and minerals. The payback period for a treatment plant to have such outcome can be only a few years. Therefore, it's only a matter of identifying industries which can benefit from the use of treated wastewater and finding appropriate treatment systems to produce fit-for-purpose water. We had an opportunity to work with Tamil Nadu Water Investment Company, which is operating recycling plants in Tirupur to treat textile effluents. As you may know, Tirupur is considered as Textile Valley. 922,000 cubic meter per year of wastewater generated from 200 textile industry units are treated by 9 effluent treatment plants to produce recyclable water and brine solutions. Victoria has clearly established guidelines for the use of recycled water, and it has treatment technologies that can enable recycled water to be supplied both cost effectively and safely. However, the uptake of recycled water remains low due to the lack of awareness of its potential as a cheap alternative supply for most water users, and also the community perceptions about the quality of recycled water. What is next in the Sri Lankan context with respect to producing fit-for-purpose water? We would like to hear from you. We know the perils of stormwater and flooding. However, we have techniques to manage stormwater through water-sensitive urban design, sponge city designs, sustainable urban drainage systems, and low-impact developments. We also have expertise to harvest stormwater. These are latest developments in transport, treat, store, and discharge stormwater. Captured stormwater can be treated by a series of media filtration to remove phosphorus, metals, nitrate, E. coli, and organic matter before being recharged to aquifers. In the Australian context, population growth and urbanization are going to increase the impact of stormwater and flooding. Therefore, working with natural processes to improve the ecology of water bodies is considered as an important aspect. Develop treatment techniques to remove emerging pollutants, improve the performance of nature-based systems such as wetlands, develop policies to encourage public engagement, and revisit existing regulations are underway in Australia. What do you think we need to consider in the Sri Lankan context? Let us move on to our last alternative resource, brackish and saline water. The total dissolved solids, termed as TDS, of brackish water is between 1000 and 10,000 milligram per liter. TDS of saline water is more than 10,000 milligram per liter. Seawater TDS is around 35,000 milligram per liter. Membrane desalination is already being used in Sri Lanka in various scales to obtain fresh water from saline or brackish water. Reverse osmosis and nanofiltration membranes are being used, although challenges in concentrate management are not completely solved. However, designing and installing desalination systems are quite easy and will improve the water supply to industries situated along the coast. Recovering salt from the brine can even make the operating costs negative in medium and large scale desalination plants. A study shows that a large scale reverse osmosis plant with 25,200 cubic meter per day of feed flow, if operated with nanofiltration followed by reverse osmosis as well as crystallization, will have 92% water recovery, produce 19.5 kilograms of salt per cubic meter of feed, and have negative $0.49 to negative $0.68 per cubic meter of water operating cost. These types of information are quite valuable for industries aiming at circular economy. In the Australian context, desalination is considered as a source providing additional water security for various purposes. So what is next in the Sri Lankan context? Again, we would like to hear from you. This slide shows the flow of information. In Victoria, integrated water management forums carried out by various integrated water management partners could inform the outcomes to water corporations to consider in their corporate plan and urban water strategy. This will help local governments to develop council plans and strategies accordingly, which will then allow the Catchment Management Authority to develop regional strategies on waterways, flooding, and catchment. This will then lead to the Victorian government to include integrated water management in the state policy and sustainable water strategy. Where to from here? I would like to keep this slide blank. However, our discussion so far inform how industries can utilize alternative water sources and contribute to the sustainability of water. Some of the things we could think are: form integrated water management partnership among industries and universities, identify collaborative opportunities, and formulate appropriate projects. It is well worth thinking of sustainable development goals in all our collaborations. When the water is safe and secure, we preserve the health of many ecosystems, such as wetlands and rivers, marine and coastal, forests and agricultural, and thereby maintaining the biodiversity of those ecosystems. If we observe very carefully, ecosystems and their biodiversities are the essence of our life. So I think it will be fitting to conclude my presentation by going through the Sustainable Development Goal 6, water and sanitation. It has 6 action targets on drinking water, sanitation and hygiene, water quality, water use efficiency, integrated water resource management, and water-related ecosystems. It also has 2 implementation targets. One is international cooperation and the other one is participation of local communities. The graph shows integrated water management contributes either directly or indirectly to all other targets of SDG 6. Our consortium look forward to collaborating with you all. Please feel free to provide your comments and needs. Our collaboration should contribute to make Sri Lanka a model island that excels in integrated water management. Thank you again.
Okay, thank you very much, Professor Jagathisan. So thank you very much for the good eye-opener, and it's a very informative presentation. I will, to preserve the time, I will keep all the questions to raise later. So our next presentation, I will introduce the next presenter, Professor Yuan Song Wei. Let me introduce, probably some of our industrial participants may not know him, but for University of Peradeniya and for the same center where I am standing in, he's not a new person. He's one of the pillars who has helped us to build this laboratory. So Professor Yuan Song Wei is the Director of Laboratory of Water Pollution Control Technology, Research Center for Eco-Environmental Sciences, RCWS, Chinese Academy of Sciences, Deputy Director of CAS, TWAS, Center of Excellence for Water and Environment, CEWE. He was awarded Bachelor of Fine Chemical Engineering from Jiangxi Polytechnic University in 1990, then a Master of Environmental Engineering from Dalian University of Technology in 1995, and PhD in Environmental Engineering from RCWS, Chinese Academy of Sciences in 2000. He worked as a postdoctoral at TNO Environment, Energy and Process Innovation, the Netherlands from 2001 to 2002, and worked as a visiting scholar in EAWHA, that is Swiss Federal Institute of Aquatic Science and Technology, from March 2008 till March 2009. Professor Wei's research interests focus on water treatment, wastewater treatment and reclamation, sludge reduction and resource recovery from sludge, animal manure biological treatment, river restoration, etc. He is the principal investigator of over 30 projects funded by National Major Science and Technology Projects of Water Pollution Control and Management of China, National Science Foundation of China, Chinese Academy of Sciences, local government and enterprises. Professor Wei has published over 300 peer-reviewed journal papers, including over 140 international journal papers and over 20 authorized patents. He was awarded the second prize at the State Scientific and Technological Progress Award of China in 2018. Professor Wei is going to present. His topic is application of membrane bioreactor in industrial wastewater treatment. So over to you, Professor Wei. You have 20 minutes from now.
Yeah, and many thanks, Professor Kopich. So it's my great pleasure to share my slide. So let me see. 8 minutes. Okay. So can you see this slide? Okay. So I will go. So many thanks for the Professor Kopich to introduction. I will brief to introduce our work. So for this, I will these 5 parts. for the membrane bioreactor. Maybe so lots of people know this, but Professor Xiaomin told me there's a lot of people from the industry. Maybe I will brief introduce the MBR. As we know, for the membrane bioreactor, especially for the wastewater treatment, so it's very cost-effective technology for wastewater treatment and industrial wastewater treatment. So generally, this is a membrane is used to replace the sedimentation for the conventional aqueous sludge process. So as we know, for this membrane separation process, there are different membranes. Like the microfiltration, ultrafiltration, and nanofiltration, and RO. Generally, it is used in MBR, use the microfiltration and ultrafiltration membrane. In China, the ultrafiltration membrane is often used. So there are different membranes, like the flat sheet membrane, tubular membrane, and hollow fiber membrane. So there's something coupling the biological and physical units. So you can see this is the figure shows the wastewater treatment plants. That's the biological process combined together with the membrane separation. This picture shows the hollow fiber. So there are also lots of membrane configuration from different companies, countries, like the hollow fiber. There's something like the noodle, hollow fiber. There's a flat head, the Cupida, and Chinese company, and this is from the tubular. So, and as we know, we often mention the MBR, membrane bioreactor. What is MBR? There's generally two kinds of MBR. One is the aerobic membrane. So there's two different types. One is the side stream. So the membrane is outside the bioreactor. The other one is the submerged membrane bioreactor. The membrane module is submerged into the bioreactor. Now this is the submerged membrane bioreactor. It is the most used process in this of MBR type. And we also people develop new other technology. Anaerobic membrane bioreactor is similar to the aerobic membrane bioreactor. People use membrane to replace to improve the settling. So including improving the anaerobic digestion performance. And this is technology now is paid more and more attention in the world, especially for the high strength organic wastewater treatment. So this is there different types for the anaerobic membrane bioreactor. So in my slide, so in the following presentation, I will focus on the aerobic membrane bioreactor. Okay, so this is the process for the wastewater treatment. So this MBR process generally, and in the full scale, the bioreactor and the membrane tank is separated. So this is for the operation and maintenance purpose, because this is very easy to operation and maintenance. So this one. Okay, so why people say MBR? And MBR, there's lots of advantages, but also some disadvantages. But the most important advantage is the higher quality of effluent, the smaller footprint, easy operation and maintenance, which the increasing the discharging standards. People realize the MBR maybe is one of the best technologies for the wastewater treatment and reclamation, especially in the urban area, with the rapid urbanization. The land area is become expensive. So compared to the conventional activated sludge process, the MBR can save lots of land area And so you can see from this, the fig, you can see this is conventional. So, but this MBR plant, it can save roughly more than 1/3 or half land area. So it can save, but no every technology has advantage and disadvantage. For the MBR, maybe the capital and operating cost a little bit higher than the conventional. So there's for the science MBR and supplement MBR. Generally, so we people use the supplement MBR, especially in the municipal wastewater. But for the industrial wastewater, people will use this side stream MBR. But generally in China, the supplement MBR is common used in municipal wastewater treatment and the industrial wastewater treatment. So this is the history of MBR. Maybe there we can show you this MBR technology development in the world. I think since 1989, the supplement MBR occurred. Since then, its wide application becomes true. Since 2001. When China won the bid of Olympic Games in 2008, so the MBR application developed very quickly. So this is a history, MBR development history in China. So there are different phase, stage. So especially, I think phase 2. So since then, and the MBR application in China developed quickly. So first, it starts in the industrial wastewater and hospital wastewater. So maybe this is also, this is the experience can be shared with the Sri Lanka. So you know, in industrial wastewater, it's difficult to treat by the conventional wastewater treatment technology. So as we know, compared to the municipal wastewater, the industrial wastewater treatment capacity is small. So maybe we, Sri Lanka side also can start from the industrial wastewater and the hospital wastewater, and then spread to the municipal wastewater. And now, and in China, for the improve the water quality, and the more and more MBR are applied in the municipal wastewater treatment and reclamation. So this is for the global market. So you can see the research and application increase very quickly, especially for the full scale MBR. There, people will really pay more attention about the capital ablation cost and the pollutant removal and the stable operation. So this is the global. This is in China. So you can see that the capacity is increasing very quickly. And also for the industrial wastewater also increase, but the most part is increased in the municipal wastewater treatment and reclamation. So for the China, there's the driving force for MBR. So I think that's for the world, it is a similar legislation, local water scarcity, return on investment, environment impact, public and political acceptance. But for China, except to this is the reasons, I think there's a water resource stress, shortage, and public policy and water environment stress. This is the key driving force to push the MBR the application in China. So for the research, the membrane fouling is the very hot topics. So okay, I think for the MBR design, for the MBR, maybe it's not so difficult now to use this technology in mixing. But for the MBR, there are others for the flushing, for the scoring for the membrane fouling control. MBR in the maintenance is very important. Generally, MBR the operation and the maintenance is easy, but operators also should pay more attention to the membrane fouling. The same to the research or topic here, because the membrane fouling will cause the flux decreased and also increase the operation cost. Well, this is something the membrane fouling the fix. So you can see this one, and this is for the membrane fouling control, and this fouling control. There's different method, like the physical and the chemical and the on-site and the chemical clean. So this will be done. There's lots of protocols provided by the MBR suppliers. And for the fouling control of MBR, so generally this is a cycle. So this is a new membrane. This is the initial filtration uses the membrane fouling, and this we can use the physical clean like the backwash. That will be okay. But when the irreversible fouling happened, so the chemical clean, nitrogen and the total phosphorus, generally the effluent quality is very good. So this is influent. This is effluent. Effluent is remove rate. So generally the COD remove rate is very high, more than 95%. And but also for the ammonia, it's also good, 95. But for total nitrogen, it's okay, 8. And for the total phosphorus, it's also very good. So, and as we know, for total nitrogen remove, it's difficult in municipal wastewater, especially the carbon nitrogen ratio is low. So this is also a big challenge in China, especially in the northern of China. So for the MBR, they also has very good ability to remove pathogen and virus, especially during this COVID-19 pandemic. The pathogen and virus control is very important for the public health. And it also the high remove rate for the PPCP and some EDC. So that is shows this is the performance. Okay, so and we want to know for the industrial wastewater, that is the literature. I also want to share with you all. So from this, they make a summarization for industrial wastewater. One is for the food, beverage, textile, petroleum, and literature. So you can see, except literature treatment, others followed very well with the COD concentration. So during the around 4,000 milligrams per liter COD, the remove performance is very good, and over then the other one is stable. So, but for the landfill literature, that is different. So you know, for the landfill, there are different age. So the literature, the quality is different. So that is different. And but as we know in China, MBR is widely used in the landfill literature treatment. And also we can see this is for the COD remove, and generally for this is for industries, the COD remove is very high in the food and beverage, and then the textile and petroleum and landfill literature. So, and I think, and in Sri Lanka, maybe the food processing wastewater can consider use this MBR technology to treat, and because this technology is very useful to do something like that. And this is also the similar. Okay, this is the effluent quality. So, and also, as we know, for the full-scale application, the operation, the investment cost and operation cost are very important for the operators. So you can see that for the flux, for the municipal flux, generally it's higher than the industrial wastewater treatment. And for the food beverage and for others 3 wastewater, the membrane flux is similar. And also we see the membrane life it's also very related to the operation cost. And but one thing we should pay more attention, that is the labor cost. But this is summarization from the developed countries. Maybe for the developing countries, the labor cost maybe is not a good, not a very sensitive factor. This is the conclusion is for the MBR application in the developed countries. So this you can see, this is to do the analysis for the different scenarios, 4 scenarios. And this is for the scenarios is energy consumption, membrane replacement, and the chemical consumption, labor, and the waste disposal. During this thing is the labor cost is very sensitive. But I think for the developing countries, MBR application, the membrane replacement, and maybe it's a big impact for this operation condition. So I will show you some case studies. These case studies in China. So, and this is shows the municipal wastewater. This is around in China, and this shows the petrochemical industry for the wastewater treatment, and that is something like that. So you can see the capacity is different, and this also shows there's MBR application in China. So, and this figure shows very clear. So, and you can see the capacity in China for by the MBR is roughly the total capacity is roughly 20 million cubic meter per year per day. So it's used very common in China. Is in industrial wastewater and also in municipal wastewater. So this is some the application I show you all. And others, I will show you some the MBR for some TFT LCD industrial wastewater treatment. I'm sorry, this is some it's in Chinese words. This is the EC, this is the influent, this is the affluent. So you can see that is very good. So especially for the MBR, and this is MBR. So you can see for the influent, the COD is 400 milligram per liter, and MBR is about 10 milligram per liter. So that is very good for the EU as a treatment for the RO. This is the RO permeate. So the COD is very low. So based on this is the process, this wastewater can be reused for the industry. Okay, and other one is for this small one, small scale. They use for the bean curd. You know, the bean curd is very common food in China. So during this production, they also produce some wastewater, but this wastewater is very high strength. For example, the COD is more than 8,000, but the discharge standard should be less than 60. So the treatment requirement is very high. So they use this as the ABR, the anaerobic digestion, then they combine together MBR. So you can see this is the effluent water quality. So they can meet the discharge standard. That is no problem. It's very, very good. And this is slide shows our research for the swine wastewater and food waste digestion. So in this is research is carried by my Sri Lanka PhD student Tarindo, and this year he finished his study. So you can see we use this is a secretions membrane bioreactor treat the this is wastewater. This wastewater after the pretreatment by the mechanical calculation, you can see this COD is very high, and so we use this one. So this one, and this is the operation parameters. But you can see this is the performance is very good. The COD is less than 400 milligrams per liter, and the ammonia nitrogen is less than the 40, less than 40. So this is total nitrogen, and ammonia is also very low. So this is a process can provide a very shortcut process for the swine wastewater and food waste digestive treatment. So this is our the result just show you. But this is labor scale. I hope in the future we can do the use in the full scale application. And we also show you some MBR application in Beijing. So this is the plans shows you. This is the application in China, in Beijing. I show you one case. This is full scale. This is for the municipal wastewater. So there are three plants. 1, 2 are the A2O process, and 3 use A2O MBR, the 150,000 cubic meter per day. So this is there the performance we can compare. So generally the COD and the total nitrogen and total phosphorus are better than the conventional. So this is show you a picture. And also for the energy capacity, we improve the A2O, the MBR, the aeration. So use the pass, the aeration. So this is the energy consumption. It's reduced very much. So this we make the investigation, and so that is just brief introduce the MBR technology application in China, especially in China, including the municipal wastewater treatment and industrial wastewater treatment. So, and if you have any idea and comments and question, please let me know. Thank you very much. And thanks the UOP and the JRDC to organize such a webinar. And I'm very happy to share my experience with you all. And in the past several years, I have very close cooperation with Sri Lanka, with the Ministry of Water Supply, National Water Board, and the University of Pennsylvania. And so I hope in the future we can cooperate together in the wastewater treatment, not only membrane bioreactor and also other technology. Anyway, so this is open. So thank you all. Thanks. Yeah.
Thank you very much, Professor Wei, for your very informative and presentation and giving us insight into these membrane bioreactors. So thank you very much once again. And the main objective of this series of seminars is to link industrialists with the experts in water industry. So local industries together with the foreign experts. So once again, thank you very much for spending your time and being with us. So this is the Q&A session. We have half an hour for this Q&A session. I kindly invite all participants. Since this is a webinar, you cannot raise your voices, but you can write your questions in the chat box or Q&A there. So now I have one question. Actually, the question has been raised by a participant, and the answer is also given for the benefit of other participants. Let me read the question. This was posted to Professor Jagadithan. Class A in Australian system, there are four classes of water. So the question was about this classification of wastewater. Class A has the highest quality with very low BOD, suspended solids, E. coli, virus, etc. Sorry, the question was, what did you refer as Class A in Australia? Professor Jagadithan, can you please help us to understand what are those four classes? Can you give?
I can quickly answer you. So the wastewater, when you treat, if you treat extremely well, For example, the secondary treatment, like Professor Wei showed, activated sludge process is a secondary treatment. Membrane bioreactor you can consider as a tertiary treatment. So when you produce water with a membrane bioreactor, it will have a quality of class A. So class A means the turbidity will be very small, like a less than 2 NTU. The E. coli will be less than 10 per 100 ml, and so on. There is a list. So we can share that list if anybody wanted in detail. The BOD will be less than 10 milligrams. So that type of water you can use for many purposes, like a toilet flushing, lawn moving in the lawns to grow the lawns, and also even the human food crop you consumed raw, that can be cultivated using this type of water. So then if the treatment is little bit lesser, and then you say class B, so the uses of class B will be limited. And if the treatment is very poor, it can class C or class D. That can be used for like a forestry or cotton growing and so on. So a different quality water can be used for different purposes. Sometimes you don't need to treat the water fully, wastewater fully, and then discharge into a river. So you can treat partially and you can use it for some other purposes. So that's what we call, you produce fit for purpose water. So that way you don't treat fully, so your treatment cost reduces. For example, sometimes we emphasize you have to remove nitrogen and phosphorus from the wastewater, but you don't need to if you are going to use that water for agricultural purposes. So that way you will reduce a lot of processes in a wastewater treatment plant. So that's how you produce fit for purpose water. So those are the classes. So if anybody interested, they can, I think we should give our email address to our colleagues. So if they are interested, they can contact us, we can give more information.
Okay, thank you, Professor Jagathisan. I think the organizers will share your contact details with the participants later. Now we have also talked about this industry for the water for. What is it? Is it a very new concept? Now we have heard of this industry for. So water for, this is the first time I heard. Can you just elaborate on what this water for is?
That is again the same as the industry for. So this is for with respect to water, what you do in the digitalization area. So because you can collect a lot of data now in a wastewater treatment plant or water treatment plant. So how you utilize them wisely, and then you give some feedback, quick response when some emergency situation happens. So utilizing the IT technology, that is where the water for comes. So it is kind of mainly utilizing the information technology for efficient water usage, efficient water treatment, and informing the public. We are going to have another session, and the last session of this webinar series. There are some colleagues are going to give more information about water for. So, yeah.
Okay, thank you, Professor Jagathisan. And we have a question to Professor Wei. Professor Wei, this is raised by Tilina. You discuss about CFD, computational fluid dynamics of water systems. CFD.
What do you mean?
So this is the question by Tilina. He says,
Tilina.
My question is, what parameters you look for to model CFD, and any particular software? Do you use any software to model this water quality or anything? Computational fluid dynamics?
Yes, I do some modeling, including the CFD modeling, the computer fluid dynamics modeling for improve the operation and structure to reduce the energy consumption and also to control the membrane falling. So I do some this research from the lab scale to the pilot scale and to the full scale. I think this is the modeling is very useful to optimize the operation, especially for the aeration strategy, because you know for the MBR aeration plays a very important role in the membrane falling control and also for the energy consumption reduction. So if we can use this is the CFD modeling, that will be very good. And other way, so we also use the ASM modeling, ASM. So we want to combine together this CFD modeling and the ASM modeling together, because you know we want to this is the biochemical reactions, especially based on the oxygen uptake. So we use this oxygen link together with the CFD and the ASM models, because for the CFD models, the aeration intensity, aeration mode, and aeration the operation strategy is related to the oxygen oxygen concentration in the water, and also for this oxygen is very plays important role for the biochemical reactions that we link together. So I think this will be interesting topic for research, but also useful for the full-scale application. We do some cooperation with the Beijing Geology cooperation group. So this is very useful to help them to upgrade the membrane modules and even some membrane MBR plants. I think that is a useful tool for this modeling. Yeah.
Okay, Professor Wei, do you use any commercially available software for this modeling, or you develop your own model?
This is we use the commercial modeling software, the ANSI, Fluent. ANSI and Fluent. Okay, yeah.
Right. Okay, thank you very much. And there's another question to both the experts. This is raised by Mr. Samantha. Our industry generate high oil content wastewater. Can MBR handle wastewater with very high oil contents?
Yes, I think in China, so such a practice application is used for the petrochemical plant. You know, in the petrochemical industry, there also some oil in the wastewater. So this is, I think, the pre-treatment is very important. This pre-treatment, the pre-treatment. So for air diffusion, so to remove the oil, because for the membrane generally, MBR often uses the polymer membranes. So this polymer membrane, the oil maybe is very dangerous risk for the polymer membranes, but now people also can use the ceramic membrane module. So which is a very good the pre-treatment, and also use some the ceramic membrane. That will be helpful to treat some the industrial wastewater containing the oil, but it depends on the oil concentration. If the oil concentration is very high, so they need to pay more attention to the pre-treatment.
Okay, thank you.
Yeah, I also can add quickly with our experience. Yes, Professor, exactly correct. Professor Wei said, if it's high concentration, there can be problem with MBR. But when it's low concentration, like a car wash stations, car wash wastewater, they also have oils. That oil can be removed because it's low concentration MBR. We have run, it works well. And the MBR, the advantage is a lot of slow growing microbes will be there. So they can degrade all kind of pollutants. So if you tuned well, and if you have a proper cleaning regime, yes, you can. But obviously, it's easy to have a good pre-treatment. For example, like a dissolved via flotation will remove all your the oil by floating them and taking them away and so on. So there are good pre-treatment technologies there. You can use them. And whatever escaping the pre-treatment can be treated by an MBR. So that's what we are observing. So Professor Wei is, that's how it works. Yeah.
Okay, that
Thank you
question
so
has
much. Thank you so much.
yeah, that question has a second part. I think Professor Jekathisan can answer this. The second part is that how do you compare conventional treatment combination with RO and MBR to achieve high effluent qualities?
Yes, I think, that generally what will happen when you use MBR, the quality is really, really high. Then if you want to go for RO will work a little bit better with the MBR effluent, because a lot of pollutants will be removed. So you give a very good pre-treatment for RO, because RO can foul very easily. So we will prefer MBR and RO all the time as a treatment unit if you are going to use RO. So that will be the answer. So, but sometimes it depends. If you want to manage, you can see whether the secondary effluent is reasonable. So it all depends on the quality coming out from the secondary effluent too. So, but obviously MBR will give you a very high quality product, because the suspended solids will be completely removed from the MBR effluent. But the conventional treatment, the suspended solids will not be removed. There will be some residual amount, maybe 20 milligram, 30 milligram per liter. So that will definitely foul your RO membranes.
Now in Australia, do you have standards for this fit for purpose water? Now, for example, now you have mentioned about this classification of 4 categories, but
yes,
are there standards for people to know?
They are kind of, the definition, the EPA, it defines this is what will be class A. So when you use this water for agriculture, the EPA can come and check. So EPA is the Environmental Protection Authority. So they can come and check whether your water quality, you are meeting the water quality standards. Otherwise, they can penalize you.
Okay.
So that's how it works.
Okay,
yeah.
Right. Ruan has raised a question. I think both you can answer this. What are the challenges if you implement MBR technologies for Sri Lanka? Do you think it is a sustainable solution?
Yeah, I let Professor Wei to answer first. Yeah,
Professor Wei has a lot of.
Okay, thank you, Jackie. Yeah, so I think so. If only consider for the treatment, I think maybe it's not a sustainable solution for the Sri Lanka. But you consider the water reclamation, that would be a good sustainable, because in Sri Lanka there's in the wet season and the dry season. In the dry season, the water shortage is very serious. So especially in the urban area. So in the urban area, they need lots of water to use. So if possible, in the urban area, for example, in Colombo City, so if you use the MBR technology, the reclaimed water can be used for the watering, irrigation, and flushing, something like that is mentioned. And also, as we know, in the urban area, in Sri Lanka, some urban area, there's water pollution. Can use the MBR. If we can use MBR, so one way, so we can produce a high quality effluent. So this will be very useful to improve and control, to improve the water quality of Bella Lake, or control the water pollution. And the second, this is a high quality effluent. It also can improve the water body's capacity, water capacity. So, for example, in Beijing, so Beijing, the water shortage is very serious, and also water pollution is also very serious. This is the large scale, the MBR plant application. So the water body, the quality improved, water environment quality improved very quickly, especially in the urban area. So, and also, as I told you a data. So in Beijing, each year, the total water use is roughly 30.2 billion cubic meter per year. 3.2 billion cubic meter per year. Among this, the reclaimed water is roughly 1 billion cubic meter per year. So you can imagine it can save lots of water resource. So I think that will be maybe we can consider, but we can based on the Sri Lanka conditions. So what is the priority for the water pollution control? So that is very important. Based on this, so we can start from the industrial wastewater in this will be step by step, because for the MBR and the conventional active discharge process based on the discharge standard and the water reuse, the investment cost and operating cost are now becoming similar. But the land area, it can save lots of. So that is very important. So we can consider together, not only for the effluent quality. That is my comments, and thanks. Yeah, Professor. Yeah.
Professor Jagadithan, do you have anything to add?
Yeah, I think Professor Wei has covered a lot of things, and a few more questions are there, so we will go. But okay. Yeah, I agree. Obviously, I think we should go for MBR in Sri Lanka because it is not only going to improve your water quality, it allows you to reuse the water, and also they are compact systems. So maybe development, small urban development, you can collect all the water, and you can have a very compact treatment system, and you can try to reuse. So that's what in Australia we are trying to do. In new developments, we are trying to treat and we are trying to reuse. So I will definitely encourage using MBR. But again, we don't need to blindly use MBR everywhere. We can kind of do a proper feasibility study, and it wouldn't take much time. Then we apply. So wherever possible.
Don't you find any problem with the reject water? Now about only 40 to 50% of water can be cleaned and treated. So what about the rest of the water? I mean, the reject water from your...
No, this is slightly different, Dr. Kalpake.
Right. No, yeah, I'm talking about RO.
Yeah, this is RO. Yeah. So in the wastewater MBR. So you are asking about RO? Yeah. The reject is always an issue. But what we are trying to do is, obviously we can produce salt. And also if you have another unit called membrane distillation, it's a thermal process, you can actually even collect more water. So when you use a RO system and couple with a membrane distillation, your water recovery will become 50% to 80, 90%. Then you are concentrating your the discharge or the concentrate is small. Then that can be disposed carefully. Or now the trend is people are trying to make salt, but then you have to have a proper market for salt. So that may not be a proper place to do, but there is an option, creating salt.
All right.
But otherwise we have to think about proper disposal of salt. But if you reduce the volume significantly, then disposing back to the ocean or to a brackish land may be acceptable.
Okay. Okay, there is a comment by Dr. Hasinta. I have seen the MBR system running at RIU Hotel in Ahungal.
Yes.
It treats 500 cubic meters per day.
Yeah, correct. Yeah, so it is correct. So that actually we can take it as a demonstration. and see how they are running, what we are doing. So I think sometimes we don't need to reinvent the wheel. Something maybe already there, but how we are putting everything together, make it more beneficial for everybody. So that's the kind of thing industry and university, we should work together. So then things become a lot easier.
Thank you. And this may be to Professor Wei. Can you use this technology for hospital wastewater, where radioactive wastewater also is contacted?
Yes, I think for the MBR is widely used in China in the hospital wastewater treatment. That is no problem. But for the radioactive wastewater, I don't much knowledge about this. But maybe the MBR can be used for this radioactive wastewater treatment. But the details, I don't have such experience for this. But you know, in the hospital, they also use some X-ray for this. But this is some the radioactive in the wastewater, in the hospital wastewater. We don't do some analysis for that. But generally, it's very low. Generally, it's very low. But you know, in China, in the hospital, there are very strict standards. There's a two-way for discharge. One way for the indirect discharge. They're only after pre-treatment. Mainly focus on the passenger and the virus control. After that, they can meet the sure system discharge standards. This will be after pre-treatment, they will discharge into the municipal wastewater. Another way, if they are without the sure system, they need to meet the very strict the discharge standards. So the MBR technology can be used to treat the hospital wastewater. That is no problem. This technology is also very widely used in the hospital wastewater, especially in the beginning of MBR technology application in China. So this technology was often used in the industrial wastewater, in hospital wastewater. Okay, then that brings us back to the municipal wastewater. Yeah.
Professor Wei, as a continuation of the same question, now the person Renu, she is continuing. Can we use this technology for cancer treatment water, the water from cancer hospitals? Maybe
maybe we don't know, but generally, you know, in China, some of the hospital is very huge. There is a comprehensive hospital, so including different treatment, like the cancer, different together. So that is, I think, individuals, the diseases treatment wastewater, I don't know, but for the combined together the wastewater, that is no problem. For example, in Beijing, sometimes the hospital, the wastewater is very huge. Every day is roughly more than 3,000 cubic meters per day. So they are combined together. That is no problem.
Right, thank you.
Yeah, if I may add, yeah, we don't have much experience with the radionuclide, but normally there are pre-treatments you can use, ion exchange resins. So ion exchange resins can capture these radionuclides. So that can become like a pre-treatment. Then the rest of the water, maybe they are organic pollutants, maybe a lot of phenol, there are various things from hospital there. So that can be treated reasonably well, but those are kind of very toxic to the microbes in the MBR. But the advantage of MBR is they can get acclimatized. So, but you might have to have a very retention time, hydraulic retention time in the reactor, but they can remove. So the microbes will get acclimatized. So yeah, it is a very good question. Yeah, we can follow that up. And I am not very sure Renu has any experience what they are doing now, whether she's asking a question or she's working in the hospital environment. Maybe it is good to see. Yeah. But yeah, you can have some pre-treat. And also that recently in Japan, they are going to release the tsunami, the power plant, nuclear power plant that release a lot of water, become contaminated, but they are treating and they are discharging. So that treatment, I guess maybe they are using these ion exchange resins to capture these radionuclide, but we don't know the details. But yeah, that's a good question to follow it up.
Okay, thank you. And the next question is, I think this is from Professor Nalin Wickramanayake from Open University. So his question is, can this reuse be done for a single multi-story building? I think small scale. He's asking about whether we have small scale units to reuse treated bath water for flushing. Can we treat our household water and reuse for washing, flushing?
Yes, yes, definitely.
Yes,
Definitely.
for
You
the
can.
flushing,
Yeah.
For single story buildings, for small houses?
Yes, we have simple schemes. You can do that one. I think I know Dr. Nalin.
Yeah, he used to, as I heard, he worked at Peradeniya earlier. He's a graduate from Peradeniya, as I know.
Yes, yes, I think I know him. Hi, Dr. Nalin. So yes, we have very simple schemes, but sometimes you need certain amount of water. If your water is intermittent and not much, maybe it's slightly problem. But maybe several houses together, you get a continuous amount of water. Then may be easy to have a kind of small scheme, and you can use like a small, even like a simple filtering systems, and then they go to a, mostly you can use it for irrigation, maybe small flower bed or whatever. But there are things, yes.
Okay, actually, President Nalin's question is about 100 plus apartments like coming up in Port City.
Of course, yes,
definitely,
of course, yeah, of course, definitely.
Yeah.
That I showed you an example that we have a fisherman band. We are thinking about 100,000 people will come, but then a scaled down version of 100 apartment, definitely it can work. Yeah.
Okay, we have a couple of minutes more left. If there are any burning questions from the participants, you can raise them in the last 2 minutes. By the way, Professor Jagadishan, now in Sri Lanka, usually the industrialists think that wastewater is a burden. They somehow try to get rid of this wastewater. So what is your message for general?
Our message is actually, we should not think the wastewater as a waste. It is another resource. So we should try to see whether we can reuse it as much as possible. What we are really emphasizing is, you see, the natural system is, we have a natural hydrological cycle. It rains, it goes to the ground, some overflows, and then there is a cycle happening. We have disrupted the cycle because we are capturing a lot of water and we are paving our lands. So a lot of extra water without going to the ground, it is overflowing as a stormwater. So we are somehow polluting the fresh water. So if you want to keep our fresh water intact, we have to try to get only once. Industry get maybe 1,000 cubic meter of water and it keeps trying to reuse it. So you are not tapping fresh water anymore for a very long time. It will lose because of evaporation and other things. So you just top it up. So this happened in the Tirupur textile valley. Originally, they were tapping 1.2 million cubic meter of water, but they are starting to reuse the water. So now they are tapping only 300,000 cubic meter of water every year. So you can see they have not tapping 900,000 cubic meter of fresh water every year. So that fresh water stays there as fresh water going through the rivers and various things. So that is the message we are telling. It is not only we are thinking wastewater, we are preserving the fresh water for many generations to come. But somehow, as soon as we take the water, do something, we are polluting. It is not fresh anymore. That also we have to keep in mind. So that's why we are trying to recycle within the system so that you are allowing the others to stay wherever they are. So that's the message I would like to give. This is for all of us, the entire human race. We should think about that way. But we can become like a model island actually. If we do something and we can disseminate these ideas to Maldives and various countries in the Pacific Islands, so it's a good opportunity, and a lot of active colleagues are there from various industries, universities. We should actually take this as a big dream, big challenge. We want to become a model island for in integrated water management. Think very ambitiously. And then, yes, obviously we can do that because we have a lot of knowledge base there in Sri Lanka. We have to utilize it.
Okay, the last question is also to you, Professor Jagathisan. This is from Tharinduri Tegala from China, as I know. You have mentioned when RO and desalination plant operate with full scale, it achieved negative operation cost. Can you explain this?
Yes, what happens is in the RO, you have a very high pressure pumps. So there are mechanisms. So the pressure will retain in the concentrate. So that pressure can be retapped. There are devices for pressure recovery. So if you install that pressure recovery, and then again, if you use that waste heat, if you have some waste heat somewhere, use that to add membrane distillation, combining with this RO. And also if you start to recover salts and combining all these things, then you can sell the salt for a higher price than your actual operating cost. So therefore, the net operating cost will become like you are earning money. You have a RO plant, you are producing water. Since you are selling salt, operation become like a positive in respect to money. But this is in theory for very long time. In practice, it is, you have to try very hard to make it practice. But yeah, if we try, we can do it. The technologies there is no willingness at this stage, maybe because why I wanted to produce water with RO, why I go to produce salt? That's the question. So if the industry think in a holistic manner, obviously, yes, we can demonstrate these things. These things are there in different scales. The textile valley, again, they are doing this one. They are recycling water, they are producing, or they are recovering salt. In the textile, you have to add salt to fix the dye to your cloth. So that salt is in the water. They recover almost 90–95% salt. And they send back as a solution back to the industry. We went and saw what is going out, what is coming in. There is a meter showing. So you can do a lot of work. It's a matter of sometime it can start from small places. From home, we can start to learn how to save the water. And then you extend that to, obviously, a simple thing. When we wash our hands, we just open the tap, keep washing, brushing the teeth, the tap can be open. We should close it and then do that one. People come from very harsh area, they do all those things because they know the value of water. Sometimes we don't value the water. Kind of good habits, and also observing and implementing a lot of things. That's the way to go. Yeah.
Thank you very much, Professor Jagathisan. Professor Wei, do you have anything to convey to our industrial participants? Final few words.
You mean so for the comments? Yeah. Okay, so it's very nice to meet together by the online, especially to meet the Professor Jagat. So it's my great pleasure and to discuss with you all. So, and I hope in the future we can have more and more successful cooperation in the future, not only water treatment but also wastewater treatment and reclamation. So I have a dream. So I want to maybe, if possible, in the Bela Lake. So if possible, they will construct an underground the MBR plant. So it's so why? Because in Beijing, so we have such experience. The capacity is 600,000 cubic meters per day. So you know, in Colombo, city center, the public land area maybe is not enough to make the wastewater treatment. So if possible in the future, so if possible, if can design some such project related to the underground MBR plant to treat the wastewater in the urban center. That will be very helpful to improve the water environment quality in the Colombo. I believe your country in the future will have very good, very bright future. With this is the fast development. The wastewater treatment will become a big challenge in your country, especially in the urban area. So, and also we know the water source shortage is also a big challenge. So this membrane technology maybe is a very good option for your country, for Sri Lanka. And if possible, so we would like to work together to make contribution for this to provide solution to solve this is a challenge to get for your country. So, and that is my idea. So China Sri Lanka has a long history of friendship. So we are also very happy to work together with you all in the past several years. So in the past several years, the cooperation show off us. So we can do something together. We can make something together. So that's I'm very happy and to cooperate with you. And as you know, so I have 10 Sri Lanka students and also like to promote Sri Lanka students studying in genetic academic sciences. I'm very happy to do that. So, and in the past 5 years, and the Sri Lanka students in our institute now becomes the #1 international students. In 2015, they are 0, and now more than 10. And in the University of Genetic Academic Science, there are more than 50 Sri Lanka students. So I think I believe Sri Lanka in the future they will become a very, very wonderful country in the Indian Ocean. So I really believe that. So Sri Lanka also face lots of challenges according to the SDG 6 and also SDG 11, and lots of challenges. I think the water, that is maybe one of priority for your country, for your people. If possible, so I would like to work together with you all. So I'm really happy to do that. So, and this year, so we are 2 Sri Lanka students will finish their study in our institute. So Tarindu will finish his PhD study, and the Indica also will finish his master study. So I'm really happy they can make contribution to your country, in the future. So anyway, so I'm really happy to work together with you and Professor Jeka and from other countries. So because I think this is the clean water and clean water environment is the basic human rights. So we can do something together. That is my comment and idea. Thank you all.
Okay.
Thanks.
Thank you very much, Professor Jekathisan and Professor Way, for your valuable time and sharing your expertise, knowledge with us. And for industrial participants, this is a very good platform. Now, the JRDC, together with University of Peradeniya, has created this platform. You can contact all these resource persons through JRDC. Just contact JRDC and the University of Peradeniya. You can get further information from them. Okay, so our discussion session is over. We have took more than like 10 minutes. Now I pass this podium to Dr. Gayan. He is the coordinator of the session. So please wait until he has few messages to pass to you all. Thank you. Thank you very much for all of you. Over to you, Gayan.
Thank you, Dr. Kalpage.
Thank you. Thank you. Look, look forward to meet you, Professor Jeka, in Sri Lanka.
Yes.
Yeah.
So thank you, Professor and Dr. Kalpage. So I would like to thank our guest speakers, Professor Yang Sun Wei and the Professor Jekathisan, as well as Dr. Kalpage for moderating the sessions. So also I would like to thank University of Peradeniya International Participation Division for supporting us for this organization. Actually, they have done a huge work, and they later we participated for this program as the University of Peradeniya and the staff of the JRDC. Also, I would like to finally thank the Professor Shamin Jinadasa for coordinating all these things for the organization. And we would like to join you in the next upcoming webinar series on 13th May 2021. It's about rainwater harvesting and stormwater management. Your all participation is highly appreciated, not least, but I would like to thank all the participants and those who have very nice questions for us to make the program interested. Thank you very much, and see you in the next webinar series. Thank you.